Okay, so this one is different than the others because we're not changing the temperature. So when you looked at the ones we did before, we were heating something up, so we had a change in temperature. But here, the change in temperature is 0 because we're at a flat line. So when we look at these calculations, if we're using specific heat, we get our heat is specific heat times mass times delta T. And specific heat has units of joules per gram degree C times mass in grams times degree C, so we get joules. But when we're making a phase change, the enthalpy of fusion here is 127.4 joules per gram. We just multiply it by 80 grams because all we're doing is melting that. And that makes our joules disappear. If you tried to put temperature in there and say, well, I'm at 5.53 degrees Celsius, you'd end up with units of joules times degrees Celsius, and that doesn't make sense for heat. Okay? And remember, this heat, or this temperature, is always a change in temperature.
Okay, so what if we were on like an incline? So like you're at
If you're on an incline here, then you have a change, and you go from where you end up to where you started.
Okay.
But when you're on the flat, there's no temperature change, so it'll be something like joules per gram. Or you might see something that says joules per mole, and then you'd have to use the molar mass to change moles into grams or vice versa.
Did it ever ask you like what was like the ending or like the ending or the starting temperature?
Sure, that would be a fair game question if instead of saying how much heat was used, what if it said, I had so many grams of material at this temperature, and I put in this much heat, where do I end up? Actually, that'd be a great problem for the test. What a great idea. Yeah, good job, right? It is. Yeah, it's actually, they're already printed. But that would be a fair question because you just kind of go backwards, right? So if that were the question, then you'd say, okay, I know the heat, and it's the amount to heat the solid plus melt the solid plus heat the liquid plus vaporize the liquid plus heat the vapor. So if we knew how much heat we had total and we had all the appropriate specific heats and enthalpies, you would just figure out how much you used up. You'd say, well, to heat the solid, I've got the specific heat times mass times delta T. You say, okay, I'm going to use this much here. So you figure out how much energy it takes to do this. Then you subtract it from your total, right? Then you figure out how much energy it takes here. Subtract that from your total. How much energy do I have left? And then you could find the delta T. You know, that would be a hard problem, but you could do it in steps. Yes?
The thing I'm getting confused on is, wouldn't we need to do like two of them though? Because you have to heat it into the liquid.
You don't heat it into a liquid. You heat it up to the melting temperature, and that takes a certain amount of heat. Then you melt it, and that takes heat to make the phase transition, and you calculate them differently. Okay? So heating it to a liquid, you're doing this, right? You're going to heat this up, and then you are flattening that out, and you're measuring the energy for the phase transition. So it's two different steps. Okay. So any other questions on that concept?